Finding the vertex, axis of symmetry, and x-intercepts of a quadratic equation is an important skill to have in a precalculus or college algebra course. In this video, I'm going to show you exactly how to do all these three things and how we can take these three pieces of information and use them to graph the quadratic equation that we're given. And I'm going to be showing you how to do all this with an example. So without further ado, let's go ahead and jump into it. By the end of this video, you should be feeling a lot better about how to do these types of problems. We're gonna sketch the graph of the quadratic function, identify the vertex, axis of symmetry, and x-intercepts when we have the function f of x equals 16 minus 1/4 x squared. So before jumping into how to solve this type of problem, I want to just take one quick second to point out different formats that a quadratic function can be in. There's basically two main kind of forms that a quadratic function can take. And maybe you've seen these before, but basically they could be either y equals ax squared plus bx plus c, or y equals a times x minus h in parentheses all squared plus k. So these are kind of the two main forms. One thing I kind of want to point out here, just terminology of what these are called. The way I learned it is a little bit different than some textbooks, so that there's a little bit of a discrepancy in the way that different textbooks describe these different forms. The way I learned it was that this first one here, ax squared plus bx plus c, was considered standard form, and then this one down here is considered vertex form. A times x minus h all in parentheses squared plus k, I learned was vertex form. Some textbooks though, like the textbook where this example problem came from, considers this to be standard form, and it doesn't really give a name to what this first one is. So just something to kind of keep in mind. I am gonna mostly be referring to this first one as standard form and this second one as vertex form, because I think the names make a little bit more sense personally. And that's the way I learned it. So maybe that's why I think they make a little bit more sense, but just be careful to kind of cross-check this to how your textbook or your teacher or professor has talked about different forms of quadratic functions, and make sure you know how, the terminology I'm using kind of corresponds to the terminology that your class uses. So just be careful of that. In this example we have here, we have f of x equals 16 minus 1/4 x squared. This doesn't exactly look like either one of these options. But we can somewhat easily kind of rearrange it to put it in a form that looks like either one of these two options. So that's generally how I would recommend starting out these problems. There's kind of a nice little shortcut way to figure out the axis of symmetry and the vertex of any quadratic equation, whether you have it in this standard form or vertex form. And I'm going to be talking about how to do that, obviously, but you typically want to basically rearrange whatever quadratic function you're given into one of these two forms in order to do this type of problem. That's kind of your general rule of thumb. Personally, I like working with the vertex form more, just because it's a little bit easier to graph a function that's in this vertex form. However, there's a lot of cases where you're given something that you can get to this standard form here, and it's really not that much more difficult, honestly. So in this case, really what you always want to kind of do, obviously you have your x squared stuff going on kind of before your constant terms out here at the end. So in this case, we have a constant term and then an x squared term. Probably the best way to start would be to just kind of rearrange these terms. We're not really changing the equation at all. We're just writing the addition of these two terms in a different order. So negative 1/4 x squared plus 16 is the same as 16 minus 1/4 x squared. And now we can kind of compare this to either one of these two forms here. So you can see that we have basically, well, let me just kind of talk about this in two different ways real quick. We can either say that we have negative 1/4 x squared plus 0x plus 16. And you can see in that case, it's pretty easily comparable to this form, right? Where we have a is negative 1/4, b is 0, c is 16. Or we can write it in this form where we have basically a being -1/4, the x minus h being x minus 0 all squared, because x minus 0 is the same as x minus 0 squared is the same as x squared, and then plus 16 being our k value. So both of these equations that we can kind of get it into these two different formats, these two equations are exactly the same. If we simplify them, they both simplify back to what we had here in the last step. So we can kind of proceed from either one of these two spots, basically. So I'll just kind of quickly touch on how to do both. Just kind of circling back to what we're looking for here, we want to identify the vertex and the axis of symmetry and the x-intercepts. So the vertex is generally going to be the place that's best to start. Once you figure out the vertex, the axis of symmetry is pretty easy to figure out from there. So just to kind of quickly talk about both of these types of forms we can use here. If we get it into this standard form, the ax squared plus bx plus c, we can find our vertex simply by saying it's always going to be negative b over 2a. So negative, in this case, b is 0, so negative 0 over 2a, 2 times -1/4. And if we were to simplify this, 0 divided by any number is 0. So our vertex, or I'm sorry, the x coordinate of our vertex. So basically the x coordinate of our vertex would be given by this equation. So it's going to be 0. Okay. And then from there, what we can do is we can just take x equals 0, plug it back into this equation. So that would be -1/4 times 0 squared plus 0 times 0 plus 16. And simplifying this down, this would just be 16. So our vertex would be at an x coordinate of 0 and a y coordinate of 16. Okay, so that's how we can do it from this kind of standard form. From the vertex form, the reason I like the vertex form more is once you get it in this vertex form here, it's very, very simple to see where the vertex is, and that's why it's called the vertex form. The vertex is always just going to be at hk for whatever h and k value you have plugged into your formula. So in this case, it's 0, 16, because we have 0 right there, -6 or positive 16 right there. So you can see in both cases, we got the same vertex, 0, 16 for both, but we just kind of used the different formula depending on if we had it in this standard form or in this vertex form. If you're in this standard form, you just use -b over 2a. If you're in vertex form, it's just hk. -b over 2a for the x, and then find the y from there, I should say. So that's why I personally like the vertex form a little bit more, just because it's in a form where it directly tells you exactly where the vertex of the quadratic function is. So from the vertex, if we now want to look for the axis of symmetry, that's really just going to occur at whatever the x coordinate of your vertex is. So the axis of symmetry is just going to occur at x equals whatever the x coordinate of your vertex is. So x equals 0. Okay, and then that's always going to be the case for any quadratic. Once you find your vertex, the axis of symmetry is just that x equals whatever the x coordinate of your vertex is. Okay, so now we need to find the x-intercepts. So to find the x-intercepts, all that really means is where your y value is 0. So to figure that out, all you really have to do is set your equation equal to 0. You can use any of the 3 versions of our equation we have here. So we can use back, or I guess in this case we have 4. We kind of rearranged it into a couple different forms. We have those, and then we have these as well. So any of these should give you the same thing, right? All 4 of these equations that I've circled here in yellow, they're all equivalent equations. So really any of them we want to use, I'll go ahead and just go back to the very beginning one, the one that was given, and we just set this whole equation equal to 0. So we'll just have 0 equals 16 minus 1/4 x squared. And then from there, you basically just have to solve for x. So we'll add 1/4 x squared to both sides. Okay, because that'll cancel with that. Then we will times both sides by 4. 16 times 4 would be 64. And then we will take the square root. We actually have to take the positive or negative square root of both sides. So that'll cancel with the squared. And we get x equals plus or minus square root of 64 is 8. So plus or minus 8. So basically we have two different x-intercepts at x equals -8 and x equals +8. So real quick, just to kind of point out, whenever you take the square root of both sides of an equation like this to cancel out something squared and solve for that thing, you always need to take the positive and negative square root, because if we kind of go back, back to this step here, if we plug in -8 for x, so we get -8 squared gives us positive 64. Positive 8 squared also gives us positive 64. So just make sure you're taking the plus or minus square root on a step like that. So that's really all the three things we had to find there. Then we have to sketch a graph. So we're not quite done yet. We do have to sketch a graph. Okay, so to do this, we have a few different kind of pieces of information here. Okay, so I've labeled my axes counting by 2s. Basically, we know that we have a vertex at 0, 16. So that's generally the easiest place to start, is just by graphing the vertex of your quadratic. So that's at x equals 0 up to y equals 16. So that'll be right there. Then we know that we have an x-intercept at -8 and at +8. So that'll be -8, +8 as our x-intercepts. And then since we had an a value, basically our x squared term had a negative coefficient, that tells us that it's going to be a downward facing parabola. So essentially we just kind of draw a parabola from that vertex going down through those x-intercepts. Wasn't a great drawing. We know we should have an axis of symmetry at x equals 0, which is basically just the y-axis. So it should be symmetrical. Obviously that's not a perfect drawing, but it's a good enough sketch to get the idea. So that should be it for that first problem. Now, all this is great, but trust me, there's other stuff that you're going to want to be familiar with when it comes to function manipulation. Like, for example, how to add two functions. Fortunately, I have made a video on how to do exactly that. Just go click right there so we can keep building on this, and so I can show you another very important topic that you're going to want to be familiar with.